Hello, welcome to another video. 6.4 more Ferris wheels. So let's kind of jump into. I have some notes already for us on the side. So we can kind of just talk about the first parts up for our sorry for our ready problems. So again, let's kind of dive into what an even function is, right? So an even function is symmetric with respect to the y-axis, right? Think about this as you're able to fold it across the y-axis, okay? So like I think people would call that like, I don't know, hamburger or hamburger style, whatever you want to call it, right? I'll talk about what this means in a little bit. And an odd function graphically is symmetric with respect to the origin, and I'll talk a little bit about this as we kind of go on, okay? Okay. So I think even functions are easier to kind of like visualize. So I always want to draw a little dashed line or just a line here. This is my y-axis, right? That's important. And think about this. If I fold this up, so if I were to fold this, um, will stuff align? Will my graphs be the same? Absolutely not, right? Like, no. So it's not an even function, right? Because this does not match with this, okay? And it should. Now let's talk about an odd function. So an odd function is symmetric with respect to the origin, okay? So what does that mean? That means that if I rotate it 180 degrees, so let's just kind of, I'm gonna take this. I'm gonna, oops, not like that. Let's, let's go, right? So, okay. And I'm gonna rotate this 180 degrees. So to make sure we know what 180 degrees is, let's kind of talk about if I rotate it there, that is 190, right? Sorry, that's 90 degrees. Um, so I'm not done. I need to keep going, right? So 180 degrees is right there, right? So an odd function is if I can rotate it around the origin 180 degrees, it will be the exact same. So these two are the exact, this is 180 degree rotation, and they're the exact same. They're the exact same. Okay? So I know that that's an odd function right off the bat. Another way you could do this is that let's just kind of think about this as a point. So this is a negative x, positive y point, right? I don't know the x coordinate for it. I don't know the y coordinate. But an odd function means that I can negate both of them. So if I negate both of them, that means that negative x, negative y. So this will become x, comma, negative y. Do I have this point? X, comma, negative y? Yes, I do, right? So visually, I can rotate this and it's an odd function, okay? Let's go to number two. Again, make my little line there. Can I fold it? Folding this. Folding this. If I fold this, will it be one graph? Yes, right. This and this will match up. Everything else, this entire part and this part will be able to match up correctly, right? So this is an even function, okay? Um, let's go to three. So again, three, drawing my little y-axis there. If I fold this, it's not going to be an even, right? No even because I'm folding this, and what is it going to tag along with? Nothing, air, right? Completely empty. So I can't do that. Let's think about if I were to rotate this. So again, I'm using this to kind of rotate this. I'm going to rotate this 180 degrees. So this is 90, this is 180, and boom, right? These two are the exact same. This is a 180-degree rotation. So again, this right here is an odd function. Okay, very, very nice. Um, what about if I had rotated the other way, right? So let's just kind of throw this, let's paste this. So again, 180 degrees across the origin doesn't really matter, right? Because if I rotate it 180 degrees this way, it's the same thing if I had rotated it this way, right? So this is 90, 180, right? Same concept. So that would be an odd function. Here, really quick, I have my y right here. That's my y-axis, right? So then let's kind of think about if I fold this up, if I fold this together, will all of them match up? Well, all of them match up. And yes, they will. This is an even function, right? Think about it like that. If I fold these up, if I fold them all, you get an even function. Let's talk about 5. So again, I have my little x's there. Now let's think about if I fold this in half across the y-axis, will everything align? Not quite, right? This and would need something to be around there, and that is too far. So it's not even, not even. What about an odd function? So again, if I were to rotate this entire thing, right? I'm going to rotate it 180 degrees. I'm going to get to the exact same point. This is an odd function, okay? And let's also think about this as like x comma y. Now, if I were to do this for it to be an odd function, I have to negate negative x, negative y. So is this point negative x, negative y anywhere on here? Negative x, negative y. So negative x, negative y, right here. Right, this is negative x, negative y. So that seems about right. Okay. What about here? So across the y-axis, so automatically we know that this is not an even function, right? Not an even. Now, let's say I have a point here. This point is negative x, negative y. Now, if this is supposed to be an odd function, I should be able to have x comma y. Is that point x comma y anywhere on here? No. So this is not odd either. This is neither. Okay, very nice. Here, this will help us a little bit more with the point system. So again, fold this in half. Does it match completely? No, right? This is not an even function. Now let's think about a point here. So this point here is going to be negative 1 comma 1, right? So then negative 1 comma 1, if I negate this, I should have 1 comma negative 1. So it's 1 comma negative 1 here. Yes, this is an odd function, right? This is odd. You can do this again for other points. So for example, here I have negative 2. Well, I'm going to say negative 4 comma 2. If I negate negative 4 comma 2, becomes 4 negative 2. I also have this point here, so odd. Okay. What about this right here? Again, I can't fold this, right? It will not overlap like a sandwich or whatever you want to call it. So not even. What about odd? So if I were to rotate this 180 degrees, let's do that. I haven't done that in a little bit. Copy, paste image, right? And now I'm gonna here rotate 180 degrees. Yep, right. These two are exact same. So it's 180 degrees. So it's symmetrical around the origin. Okay. What about 9? So 9 really quick. What do we see here? Right, it's perfectly symmetrical. This folds with this folds with that. Off the top of your head, right? Even. Number 10. Okay, so number 10 here, we have a line. Can we tell that, right? So it's not going to be even automatically. What about odd? So we can do this graphically. copy, paste, right? So if I rotate this 90 degrees, 180 degrees, these two are not the same, right? Not the same at all, because this crosses 0, comma 1, and this doesn't even cross that point, right? So doing it with the numbers, if I have 0, comma 1, an odd should be 0, negative 1. So is 0, negative 1 on this? No, right? So it's neither odd nor even. Okay, cool. Let's go into describe the transformations on the parabola in the following equations. So parabola, my parent function is y is equal to x squared, right? Okay. So number 11, there is a plus 5 here. What does that mean? There is a vertical translation or a shift up by 5 units. Okay, cool. Number 12, minus 1. So there's a vertical translation shift down by 1 unit, right? Okay. 13, we have this little right there, right? What is that going to be? There's a reflection, okay? So there's a reflection over the what? This one's tricky. It's over the x-axis, okay? So let's kind of draw a little photo here, and just so we can see it. So negative x squared is something like this, right? Right, so my original parent function is here, so this is my x-axis, so it's reflected over this, okay? There's a 4 there, that is a vertical stretch, right? So it's a vertical stretch by a factor of 4. Okay, cool. That was pretty straightforward. 15. Given the equation, fill in the actual values on the graph for the midline, the amplitude, and the period. Okay, so my amplitude. So 25. Let's kind of label these. So my 25 is my amplitude. So if I have h of t equals to, let's do a sine of bt plus d, right? So a is amplitude, so this is 25. So my amplitude here is equal to 25, 25, 25. Okay. My midline. So my midline is always going to be the d value, right? So my a is 25, d is 30. So my midline here is y equals 30. 30. Now, I will be honest with you. I don't particularly, if this was in degrees, they should have given me degrees there. So my b is equal to 18, right? This is my b. Now, as we might know, period. So period is equal to 2 pi over b, or 360 degrees over b. So in this particular case, um, I I'm gonna go with doing 360 over 20. What was my b? Maybe it was 18. which is equal to 20 degrees, right? So my period is 20, well, no, that's 20 seconds. Okay, 360 degrees over my B, which is a frequency, so this should be 20 seconds. Okay. Um, we might also talk about this as a in radians. So it would be 2 pi over 18, which is equal to pi over 9, pi over 9. Okay, but this is what we should kind of have. Okay. Um, okay, good. Match the graph with the correct equation. So let's kind of talk about this. So I want to make a note that amplitude, so amplitude A is equal to absolute value of max minus min dividing this by 2. Then my D, my vertical shift, is equal to max plus min dividing this by 2. Okay, so it's an average. Okay, so let's kind of start off with letter A. So here we have that letter A, we have the midline. So the midline here is y is equal to negative 10, right? So automatically we know that it's going to be 1, 2, or 3 right off the bat. The amplitude is the same for all of them. So what we're comparing now is this right here, right? So again, my period is equal to 360 degrees all over um, my B, right? So then let's kind of, for letter A, let's kind of figure out what my period actually is. So I like to think about my period as from 0 all the way to here, right? Um, which is very close to 10. So I would maybe say that that's about 9. Um, does this say this is about 9, right? So then my period here is 9 is equal to 360 over B. And then to solve for B, we get that B is equal to 360 over 9, which is equal to 40, which is equal to 40. So then we know that this should be 2. So this A pairs up with 2, okay? Because this is 40 right here. And we can maybe scratch this. Let's just put a check mark to note that we used this. Okay. Okay, cool. Let's do letter B. Okay, so B here, my midline is also y equals to negative 10, right? Pretty fair. So I know that's either going to be 1 or 3. And now let's kind of think about more what my period is. So my period goes from this right here up until here. So I would say that that's about, I'm gonna say like 17, maybe like 17 or 18 even. So then again, my period, let's call it 18. And then so then my B is 360 all over my 18, which is about 20. So right off the bat, that would be 1. So A is 2, B is 1. Okay. Let's go with letter C. This right here again looks like it's y negative 10. So by process of elimination, this is the only one that has a negative 10 there. Let's just kind of do it to be more exact. So my period goes from here up to there. I'll call that like 6, I would say. So then my B is equal 360 over like 6, and 360 over 6 is 60. So that works really well. So this is 3 right there. This is 3. Okay. Okay. Let's go to D. So let's kind of first try to find out um what our amplitude is, I would say. So our amplitude, as I discussed, is the absolute value of max minus min divided by 2. So my max value here, let's call that, I'm being really like, well, yeah, we can be conservative with our answer. So this is like 30. This, we'll call that like, I'll say 35 minus my minimum. My minimum happens here at like, let's say 5. Why not? All over 2. So this is 30 over 2, which is 15. So my amplitude should be around 15, which the only one that's close to that even is D right here. So I'm going to say that that's going to be 4. I don't know if I picked bad numbers. Um, maybe this is closer to like 37, but to me that looks like halfway mark. So I called it 35. Oh, I know my mistake here. So this was minus 5. So 35, this is 40 actually. This is 40. Divided by 2, right? So this is 20. So there you go. Letter E. So letter E now. Again, let's find my amplitude. So A is my max. This is 40, 20, 30, 40, 50. We'll call this 55 minus my min. This is negative 20, negative 30. Let's say negative 25 all over 2. So 55 minus negative 25 is 80. Divided by 2 is around 40. So then, okay, we're between. So both of them have 40 as my amplitude. So the thing that's going to determine this is my midline. So my midline D is equal to 55 plus negative 25 all over 2. And in this case, 55 minus 25 is 30, divided by 2 is 15. So D is 15. So 5 should be E, or E should be 5. And then last but not least, by default, F is going to be 6. Okay, let's test it out though. So my amplitude is absolute value, my max is 40 minus my minimum. This is 80 over 2, which is 40, right? Perfect. And then my D is going to be 40 plus negative 40 divided by 2, which is equal to 0. So then that's 6. Okay, so very nice so far. Let's go with 17. Okay, so I did have some notes here already that we might use. I'm gonna try to talk about this in different ways. Okay, consider the point negative 4, 2, which is on the circle. So it's on the circle, okay? And this is the equation of the circle, right? So I want us to know that this is a standard form of a circle, right? So what is the radius of the circle? So I want us to kind of quickly realize that the standard form of a circle can be expressed as x minus h squared plus y minus k squared is equal to r squared, okay? Where h and k are my center, okay? So then we know that the center here is going to be 0, 0. So 0, 0 is my center. And then r squared is equal to 20. So then what is the radius? R will simply be square root of 20. Very, very nice. Okay. Now we can maybe take a second here to simplify this further. So square root of 20 can be thought about as 2 times 10. And then here is 2 times 5. So then this is equal to 2 square root of 5, right? Okay. Label the point. So we'll call this 2 square root of 5. I'm simplifying the square root, right? Simplifying it. Label the point negative 4, comma 2. So negative 4 comma 2. So right here, we'll call this A. Okay. Sketch the angle of rotation in standard form showing the initial and terminal rays. Okay. So my angle of rotation will look something like this. Okay. So what am I doing? What am I drawing? So this is my initial ray, and this is my terminal. This is my terminal right here, terminal ray, and my angle of rotation, let's change colors here so we can see it, is this entire thing, right? Oh, that's not this entire angle, right? This entire angle, theta here is my angle of rotation, okay? Okay. The angle of rotation you just drew, what is the value of sine at this point right here? So again, should be from our lecture that sine of theta is equal to y over r, right? So y is the coordinate point, and then r is the radius of this. So then for d, sine of theta is equal to y. My y coordinate there is going to be 2 all over my radius. My radius is square root of 20. Okay? I don't want my answer to be like that. How can I simplify this further? So I multiply the top and the bottom by square root of 20, square root of 20. And I'm left with 2 square root of 20 all over 20, right? So this simplifies to square root of 20 all over 10. And now we know that square root of 20 is this. So let's simplify this even further. 2 square root of 5 over 10, which is just going to be equal to square root of 5 over 5. Okay, so this is square root of 5 over 5. Okay. Now, letter E is a little bit more complex. So what is the measure of the angle of rotation? So we want to find this angle right here, right? So it has to be more than 90 degrees for sure, right? We can see that. Now let's kind of jump into our calculator and figure out what sine of this, what theta is, right? So if we know that sine of theta is a value, right? So then let's kind of go here. So sine of theta is equal to square root of 5 over 5. So then theta is equal to sine inverse of square root of 5 over 5. So let's kind of go to our calculators. What is this? Delete this. So then make sure you're in degrees, so degrees. So then sine inverse of square root 5 over 5 is equal to 26.565 degrees. Okay. 26 point, what is it? 26.565 degrees. So does that make sense? That the angle of rotation is that? No, right? Because we know that this sine and this sine right here are the exact same. So how should I go about this? Okay, so if this angle, so let's make a little triangle here that maybe helps us visualize this. So sine of theta, theta is right here. Oops. Because my opposite was 2 and my radius was this. So I found this angle right here, right? So what do I do to find this entire angle, right? So this is supposed to be from quadrant 2. We know that this is 180 degrees. So I would just subtract it from that. So I would do 180 degrees minus 26.565 degrees, which is equal to 153.435 degrees. Okay, that's one way to think about this. Because I found this little angle here, right? So that angle was 26.565 degrees. Um, I could have subtracted. Let's see what that works like. Yeah, yeah. I think that's the best way to kind of go at this. So when we were in quadrant 2, you subtracted from 180 degrees. Okay, let's talk about number 18. So number 18 is very, very similar, right? So consider this point um, on this circle, 2, -5, which is on this circle, right? What is the radius of this circle? So again, r squared is 29. So then the radius is the square root of 29. Label this point 2, -5 is going to be right here. We'll call this B. Okay. Sketch the angle of rotation in standard form showing the initial and terminal rays. So this is my initial ray from here to here. And then we're down here. Okay. This is my initial. This is my terminal. Okay. And then my essentially what I'm looking for, my angle of rotation, we'll do it a different color, is this entire angle, right? Up to there. So that we'll call that theta, right? This thing's theta. Okay. For the angle of rotation you just drew, what is the value of sine at the point? So again, sine of theta is equal to y over r. So my y coordinate there is -5 over square root of 29. I don't want to have my answer like this, right? So I multiply the top and the bottom by square root of 29. So I'm left with -5 square root of 29 all over 29. Okay, so -5 square root of 29 over 29 is my sine of theta. Okay, now letter E. What is the measure of the angle of rotation? Okay, what is the measure of the angle of rotation? So I need to measure this angle. So just by estimating it, so by an estimate, it has to be what? Think about that. Just think about that. Greater than what? Yes. Okay, it has to be greater than 270 degrees. Because this is 180, this is 270 degrees. So it has to be greater than 270, but less than 360, right? So that's kind of standard. Now, let's kind of think about sine of theta. So theta here, sine of that point was this. Okay, let's find that. So let's go to my calculator, and then let's do um second sine inverse of negative 5 times square root of 29, dividing this by 29. So that's negative 68. So once you have that negative 68, how should I make it a positive? So think about a coterminal angle. So to get it to become a positive angle, I add my 360 degrees, which is 291.8 degrees. Okay? So this right here is equal to sine of theta plus 360 degrees, right? Which was 291.8 degrees. Okay. Um, Now a reference angle. We've talked a little bit about a reference angle, I hope. Um, but I think doing it like this and figuring out that sine of this is equal to the theta. So theta is equal to um, theta was equal to negative 68.198. 199 degrees, let's just call that, right? So that doesn't make sense, right? I want to have a positive angle, so I added 360 degrees to it, right? Because here, sine is supposed to be negative, right? So we're in that quadrant. Okay. If you talk about a reference angle, so my reference angle is equal to um, let's call this alpha is equal to tan inverse of y over x here. So tan inverse of negative 5 over 2, let's do that. So tan inverse of negative 5 over 2 is negative 68, right? So then we do get negative 68. Same concept, right? So again, you have to add 360 degrees to make it a positive, okay? In this one, we didn't have to add anything because our angle was positive, but we had to subtract it from 180 degrees to figure out what this entire thing was, okay? This was finding our amplitude and our vertical shift. Period is 2 pi over b or 360 over b. In this case, we used this definition of it, but it's important to be able to do both. And we talked about even and odd functions, okay? I hope you have a great rest of your day.